Being alive in this world means we interact with physics, whether that be catching a ball from afar, jumping off a high ledge, the drip of water from the kitchen sink, or even the slow fall of a leaf. All of these things, we are able to predict their motion with just a few pieces of information, all thanks to a guy named Newton. But are we really able to predict the motion of everything in the universe? Classical physics is the study of the physical world visible to the naked eye. It's based in mechanics, electrodynamics, thermodynamics, and optics. I will focus on mechanics because it is the one I am most familiar with. For this ball, I can predict the velocity it will be right before it hits the ground, knowing that the starting velocity is 0. The height is 0.75 meters. Using the same ball, I can predict how far it will go if I throw it at a specific angle. Now that I have established visually that we could predict the position and velocity of an object, what would happen if we shrunk it down to the subatomic level? What would happen then? Would the ball leave my hand at a faster or slower rate? Would the ball just disappear when I throw it? Although some of these things seem straight up ridiculous, quantum mechanics unfortunately makes some of these things possible. I say unfortunately because one of the key things about quantum mechanics is that you must throw your intuition away. I would like to introduce some of the topics that I find both interested me as well as both make me hate physics. To start off, we have to talk about the double slit experiment. In this experiment, a beam of particles, let's just say they are electrons, is directed at a screen with a detector that records the pattern of particles that pass through the slits and strike a second screen. The surprising result of the experiment is that the particles behave as if they are waves and create an interference pattern on the second screen, with regions of bright and dark fringes. This pattern only occurs when both slits are open, and not when only one slit is open. When one slit is open, the electrons trace out a single line compared to the wave interference pattern when both slits are open. This shows that the electrons behave both like a wave and a particle. This experiment is one of the most popular and fundamental experiments in all of quantum mechanics, as it showcases many phenomena found in quantum mechanics. The uncertainty principle is a fundamental concept in quantum mechanics that states that certain properties of particles, such as their position and momentum, cannot be precisely measured at the same time. So it basically says that the more precisely you measure the position of a particle, the less precisely you can measure its momentum, and vice versa. The Schrödinger's cat experiment is a thought experiment in which quantum mechanics that was first proposed by physicist Erwin Schrödinger to highlight the strange and counterintuitive nature of quantum mechanics. In the experiment, a cat is placed in a sealed box with a vial of poison that will be released if a radioactive atom inside the bomb decays. The decay of the atom is governed by the laws of quantum mechanics, which means that it is impossible to predict when it will decay. Until the box is opened and observed, the cat is considered to be in a state of superposition, where it is both dead and alive at the same time. According to the principles of quantum mechanics, the act of observation collapses the superposition, and the cat is either alive or dead, but not both. This means that the observation itself determines the outcome of the experiment. Now you can see the significance of the double slit experiment, as the uncertainty principle can help visualize why we can have both a wave pattern and a line pattern, as well as how Schrödinger's cat can explain that the electron is not just going through one slit, but it's going through both at the same time, and bounces off each other to make a wave. Ultimately, I think in most everyday life, we are able to predict the motion of most things. To the average person, the answer to this question would be yes. But bring it down to the fundamental particles that make up this world, and I would say, no. We fundamentally cannot predict the motion of everything in the universe. Looking into quantum mechanics has been a lot of fun. I found out that this weird subject has found use in areas of our lives, including the device you are watching this on, GPS, and quantum computers. Who knows? Teleportation might become a real thing, as well as man-made wormholes. We just have to hope for it in the near future. I do think this project came out very successful. Although my sources mostly come out from YouTube videos, I trust that they come from reputable sources as they have been reviewed positively from the communities surrounding them. In a subject as convoluted as quantum mechanics, these videos have had a great impact on helping me visualize and simplifying these subjects. I hope you enjoyed, and please subscribe.